starting up with server-side parameter pollution. So we have already completed the API testing, and now we'll be starting with the server-side parameter pollution, and then we'll be moving on towards the labs for the server-side parameter pollution. So let's see what we have here. We have server-side parameter pollution. Some systems contain internal APIs that aren't directly accessible from the internet. Server-side parameter pollution occurs when a website embeds user input in a server-side request to an internal API without adequate encoding. So this means that the attacker may be able to manipulate or inject parameters which may enable them to. So, for example, overriding existing parameters, modify the application behavior, and access unauthorized data. So these three things can happen, and which are already more than enough to exploit the vulnerability and exploit the whole website. So you can test any user with input for any kind of parameter pollution. For example, query parameters, form fields, headers, and URL path parameters may be all vulnerable. So if we see here, there's a node given to us. This vulnerability is sometimes called HTTP parameter pollution. So the server-side parameter pollution can be also known as HTTP parameter pollution. However, this term is also used to refer to web application firewall bypass technique. To avoid confusion, in this topic we'll only refer to server-side parameter pollution. In addition, despite the similar name, this vulnerability class has very little in common with server-side prototype pollution. So so there are two types of vulnerabilities, actually three. So server-side parameter pollution is also known as HTTP parameter pollution, but HTTP parameter pollution is mostly used for the web application firewalls. So uh, in this, we are mostly mentioning it as the HTTP parameter, not the HTTP parameter pollution, but the server-side parameter pollution. And there is also one more type of vulnerability class, which is called a server-side parameter pollution. Sorry, server-side prototype pollution. So it has similar things, similar common ground with the server-side parameter pollution and server-side prototype pollution. But we will not be looking towards the prototype pollution. We will be looking at parameter pollution now. So testing for the server-side parameter pollution in the query string. To test for the server-side parameter pollution in the query string, place query syntax like hashtag ampersand and equals to in your input, and also and observe how the application responds. So here we'll see the example later on here. So consider a vulnerable application that enables you to search and to search for other on their username. When you search for user, your browser makes the following request: get user search name is Peter here and back home. So to retrieve information, the server queries an internal API with the following request: get user search name Peter and public profile true. So this is the request which our browser makes, but this is the request which is made in the backend with to an internal API. So truncating the query strings, you can use URL encoding hash character to attempt to truncate the server-side request. To help you interpret the response, you could also add a string after the hash character. So for example, you could modify the query string to the following. So what you can do here is get user search name is equals to Peter, and so this we have written here foo, which is also is URL encoding. So URL encoded hashtag looks like this, and it's percentage 23 is hashtag in URL encoding foo, and back is equals to home. The front end will try to access the URL following like this. So it will convert the URL encoding into the string, which is the hashtag foo, and public profile is equals to true. So in the node, it's essential that your URL encode the hash character. Otherwise, the front-end application will interpret it as a fragment identifier, and it won't be passed to internal API. So in the note, it is given that we have to mandatorily use the URL encode in our the HTTP request. Otherwise, it will identify interpret it as a fragment identifier. So it won't be useful for us to use it as a character, but we have to use it as a URL encoded character. So review the response for clues about whether the query has been truncated. For example, if the response returns the user Peter, the server-side query may have been truncated. If an invalid name error message is returned, the application may have treated foo as a part of the username. So this suggests that this server-side request may not have been truncated. If you are able to truncate the server-side request, this removes the requirement of the public profile field to be set to true. You will be able to exploit this to return non-public user profiles. Okay, so this can be done to retrieve the non-public user profiles. So we'll be seeing we'll be exploiting all these things in our labs, and we'll also be using the different platforms to exploit the vulnerabilities which we are learning here as well. So one of those platforms is OWASP Juice Shop, and I have already made a video on how you can download the OWASP Juice Shop on your Kali system. So please do check out that video and download the Kali version of the OWASP Juice Shop. And moving forward, injecting valid parameters. Okay, so we haven't seen this one yet. You can use this. You can use your encoded ampersand character to attempt to add second parameter to the server-side request. For example, you could modify the query string to the following: get user search name Peter, and so this is the ampersand, and you could say percentage 26 foo is equals to XYZ and back home. So this results in the following server-side request to the internal API. This will be the request to the internal API here, which is where foo is the second parameter. So review the response in the clues on how additional parameter is passed. For example, if the response is unchanged, it may indicate the parameter was successfully injected but ignored by the application. To build a more complete picture, you need to test further. So injecting valid parameters, if you are able to modify a query string, you can then attempt to add second valid parameter to the server-side request. So for information how to identify the parameters that you can inject, see the finding hidden parameters section. So we'll be looking onto it. We'll see how we can find the hidden parameters. So if we go on to this, and in the API testing as well, we have already seen how to find the hidden parameters. We have already uh, seen that error messages give us the hidden parameters, which we are not aware of most of the times in the application. It is not shown to us. So, and there are a few apps also like Burp Intruder in the Burp Suite and Paraminer, and also Content Discovery Tool, which we have discussed earlier. So, we'll be moving forward with the next topic, which is the example. Here we have seen the example. So if we override the existing parameters, which is to confirm whether the application is vulnerable to server-side parameter pollution, you could try to override the original parameter. Do this by injecting a second parameter with the same name. And for example, you could modify the query string to the following: get user search name is equals to Peter, ampersand in URL encoding name is equals to Carlos. So these are two parameters which are encoded in the same URL. So what happens here? This results in the following server-side query to the internal API. It will result in this, and the internal API requests the API interprets two name parameters. The impact of this depends on how the application processes the second parameter. This varies across different web technologies. For example, PHP passes the last parameter only. This would result in a user search for Carlos. ASP.NET combines both parameters. So this would result in the user search of Peter and Carlos, which might result in the invalid username or error message. Node.js or Express passes the first parameter only. This would result in the user search of Peter, giving an unchanged result. So if you are able to override the original parameter, you may be able to conduct an exploit. For example, you could add name is equals to administrator at the request. This may enable you to log in as administrator user. So here we have a lab for it, and we'll be moving on to the lab, and we'll see that what it wants and how to solve this lab. So the lab name is exploiting server-side parameter pollution in a query string. So to solve this lab, log in as an administrator and delete Carlos. So to solve this lab, we need to know how to use URL query syntax to attempt to change the server-side request, how to use error messages to build an understanding of how server-side API processes user input. So we have to look onto the error messages to find the hidden parameters, which we have done earlier. So it should not be a very big problem to us, and it should not be a very new thing to us. And now we have accessed the lab, and let's see what is there in the lab.
So now we'll access our lab and we'll solve it. So we'll connect our burp suite Foxy proxy, and we'll open the burp suite, and then we'll go to the proxy tab, and what we'll do is we'll go to the proxy tab and we'll turn on our intercept here, and next we're gonna do is we'll go to our account and we'll forward the request here in the burp suite, so we can check our burp suite is working well. We do not have any username and password, so only option we have is forgot password, and we'll go on to it and we'll check the backend valid username request. So we'll type an invalid username, which is administrators, as they are asking us for the administrator, but we'll type administrators, and then we'll check if they have a invalid username check here. So yes, there is a invalid username check, I guess, because if we forward the request, let's see. So yeah, we have an invalid username here. So what we'll do is we'll go with the valid username now. So we'll go with the administrator, and then as we know it's a valid username, we'll go to the proxy and we'll right click and we'll send it to the repeater, In repeater, we will test the two things we have learned today, which is percentage 26 and percentage 23, which is ampersand and hashtag. So what we'll do is percentage 26 and with the parameter, with some random parameter to check if they accept the additional request. And yes, they do accept the additional request, as it says that parameter is not valid. And if we send the hashtag request or percentage 23, we can see here that field is not specified, so we know that there is a parameter called field. So we'll check the field here, and okay, so it's passing it as normal. So now, as I have identified the issue, we have wrote field with capital F. We need to write it in the small f, as all parameters are in small letters. So we'll check the field here, and the field is we're getting some errors. So what we'll do is we'll try with percentage 23 and percentage 26. So we'll send the request, and we can see that the field is invalid. So we know that this parameter is correct, but the value is not correct. We'll send it to the intruder now. We'll highlight the value, and then we'll add the burp suit payload, and then I have pasted here a ton of words, which is keywords, which I will paste in the description, the GitHub repo. You can go and directly copy it and paste it here. Then we'll start the attack, and if we go to the intruder attack now, and we'll sort it by the status code here. If we check and we'll sort it by the status code, we can see that there are two parameters here with the valid status code, which is email and username. So we know that username already exists and email also already exists, but we didn't know the parameter value yet. So what we'll do is now we'll go back again to our burp suit, and then we'll go to the repeater, and we'll change the parameter to the email, and then we'll check what value it gives to us. So now, as we can see here, we get the email of the administrator account, but we do not want the email because we already have the email, and we tried to truncate it further, but there was no external parameter which was blocking our request. So what we're going to do is we'll go to the target. We'll see here the static js forgot password file, and we'll check the code here, which says that location should be the forgot password reset token is equals to the reset token, which will give us the reset token of the administrator account. So what we'll do is we'll replace the value from email to the reset token, and then we'll send the request, and here we get the request again. In the result we get the reset token. So what we're gonna do is we'll copy this reset token now, and we have to use it somewhere. So what is this? This is the forgot password reset token. So what we'll do is we'll go to the URL, and then we'll copy and paste the endpoint of the reset token, and then we'll replace our reset token from our repeater to the URL bar there. And what we'll do is we'll paste our reset token, and then we'll press enter, and we'll turn off our Foxy proxy. Then we'll press enter so that it passes smoothly from the HTTP. And here you can see that they say that it's not accessible over HTTP, so we change it to HTTPS. And then now here you can see we can change the password. So we'll keep a simple password like 123456. Then we'll confirm the new password again, then we'll submit. So you can see that we have changed the password successfully. And now we'll go to my account, and we'll try to log in with our account username and password, which is 123456, which we have set it now itself. We'll log in, and we'll go to the admin panel, and we'll delete the user Carlos successfully. And as you can see here, we have deleted the user Carlos, and our lab is solved. We'll refresh the page. So you can see here we have successfully exploited the server-side parameter pollution in a query string, and I'll see you in the next video. Bye bye.